All right. Are we ready?
Yeah.
Okay.
Yeah, advanced Linux. Yay.
Okay. Let's get started.
Who am I?
Yeah, that's my name, Daniel. All right.
So, refresher on the file system. Yeah, there's a lot of stuff here, but pretty much the main thing to remember is that you have this root directory with the slash. You have a ton of stuff under that, right? Like some notable ones that you're probably familiar with is the home directory where all the user home directories are. But other important things like the bin directory where all the binaries are, sbin where all the system binaries are, and etc config files, those kind of things. We're talking about some of the other ones too in this presentation. So here's the refresher. That's what the everything's a file. This is the directory structure of Linux. Okay. So how exactly do you control the permissions of these files? Pretty much every single file has three sets of permissions. There's the permission for the user who owns the file, the permission for the group that owns the file, and the permissions for everybody else, right? And there are kind of three ways that you can represent these different permissions. You can use a set of the characters, RWX for read, write, and execute, and then in turn those can be represented with binary, just a 1 with its own field, its own type field, and then that gets translated to decimal system, which if you're using the chmod command, which you use to edit permissions on files, you use chmod, and then you could use three numbers that represent the permissions that you want to use to kind of make that easier and quicker for yourself. Some common ones like 755, 777 for permissions for everything. I'm sure you've seen those before. File permissions. Cool stuff. All right, moving on. File descriptors. So, if you've looked through the man pages for common C methods in the Linux standard library, a lot of the stuff we talk about is interacting with file descriptors and using file descriptors, sending things to them, and grabbing things from them, interacting with them. So they're basically just the manifested way that Linux allows you to interact with files. There's three of them. There's standard input, there's output, and then there's error. So I'm sure you've seen before. You can redirect things to these file descriptors. If you want to input into a file, go to grab the output from the file. Then you use different file descriptors, and oftentimes arguments of certain methods will require them. And standard errors for outputting errors. And so they're used by syscalls a lot to do things with files, and we'll talk about syscalls a bit later. All right, since we're on the topic of files, let's talk about ELF files or ELF files. They're for executable and mutable file, executable mutable format. I gave a really, really in-depth presentation on ELF files last year around this time. That I frequently, I myself will reference that presentation I gave a lot when I forget things. So if you're really interested in the big internals of these files, definitely check that out. It's good to know for reversion unit stuff, or if you just want to mess with them, to write malware, those kind of things. It's cool stuff. But basically, there are three types of them. There's relocatable. So these are your .o files, object files, pretty much. They you don't really execute these files; they get included in other files. So you can think of them as kind of like libraries or modules type of things. These executable files, which means you can run them. It's pretty self-explanatory, that one. Then there's shared object or dynamic files. So these can be included during runtime. So they're dynamically loaded by the dynamic linker on Linux. And again, if you want to know how that whole process looks like, check out that other presentation I gave, because that's a whole 40-minute discussion. And they're ELF files are divided into segments and sections, which basically are just two different perspectives, two different ways of looking at the file, depending on if you're loading the file or if you're executing it. So sections are going to deal with a lot of the information that corresponds with relocating, which is when you're taking importing code from one file to another file. And segments will have more the actual instructions for executing things like that. For loading executable files, make sure that all that gets handled properly. cool topic. All right, so let's talk about these two directories, proc and sys directory. These are virtual file systems, which is kind of a weird term because like, isn't everything on computer virtual? No. But yeah, these files are immaterial contents. They are not like actual. They're just basically they're files, but they're just Linux's way of representing data about hardware and about drivers and that kind of stuff. Proc, you'll have a lot of data about processes. It's mostly read-only type stuff. There's some stuff you can write to, like you can change the host site of your machine by writing to a file in the proc directory. But yeah, it's mostly metadata about processes. And again, it's just like a kind of a representation of that data. It's not, you're not actually like interacting with the data itself, so to speak. It's just a way for you to see it. And then sys is kind of the same idea as proc. It's just that it's mostly stuff about the hardware of the machine that you're on. Yeah. All right. Next, services. So what are services? They're basically applications that they usually start on boot. Usually want them to start on boot. Sometimes you don't. It just depends on what it is. But yeah, they run in the background, so to speak. And they're just common services or common applications that you want to have running and have a nice, fast way to run them without, something reliable to get them going. And there's many ways to manage them. You've definitely probably seen systemd if you've been on a Linux machine. It's the most commonly used. A lot of people have problems with it because, I don't know, it's like loaded, it's weird sometimes. But I think it's fine, personally. But there's other options too. There's OpenRC, there's Railic, there's and they all work pretty well. Syncd is definitely the most bloated, but it's definitely the most common one out there. So if you're going to get familiar with any of them, it should be that one. Yeah, but as with most things on Linux, there's always like 200 different ways to do things. So those alternatives do exist. So let's look at how you would write a service file. Pretty much there's like these different sections of it. So this example is this WPA supplicant service, which is a service on my laptop that's used for managing network connection. And so the service file, you can find these in that directory, the system directory in RITSEC. And there's like three big parts. There's the unit where you just kind of describe it, write the description, and then you can specify when it gets loaded in relative to other services and other kind of services that are required before it gets turned on, that kind of thing. You see that with the once, sometimes also respect to the service. And then the service tag, under that, you'll see the more specific stuff about executing it. So the most important one there is the exec start kind of label, where it defines like what would actually get run to execute the service when you like the systemd start WP and supplicant messaging. And then yeah, install is just other random stuff. I'm not sure why they call it install, but sometimes you'll see things in there that it's not able to use, so it's not too big of a deal. Wanted by, this kind of helps when you're like looking through errors. The wanted by will tell you you're going through a log, if that thing is included or not for other services, that kind of thing. Some more just auxiliary data. All right, so let's talk about cron. If you've blue teamed or red teamed, you've probably heard of cron in relation to Linux. We use it a lot for both of those things. It's basically scheduled tasks. So if you want something to run at a certain time every day, or a certain day every month, then you usually do it through cron tab. And the ways you would edit that is with cron tab -e. That's going to allow you to edit your own user cron tab. And then you can view the cron tabs for all the different users in the var-spool cron directory, typically. And the etc cron directory will also have some different cron jobs that you can see there, kind of system-wide. And they're separated into like cron.daily for daily tasks, monthly for monthly tasks, and hourly, and so on. And yeah, cron is pretty straightforward. You would use this great website like cron.guru to help you figure out when exactly how to label it. You have like 5 numbers that you use to represent the minute, the hour, the day, the month, and the day of the week. And so, for example, 001 star star is saying at the minute 0 and hour 0 of the first day of the month. Star means every month and every day of the week, so it doesn't really matter. Execute whatever it might be, right? That's kind of how that looks like. All right. So talking about kernel space versus user space. Now we're getting a little bit more into the guts of it. Yep. Ring 3 is the application level or the user space level. This is where you're interacting with things where you're at, right? This is when you're on a Linux machine and you're typing things in, and you're using it, you're on ring 3. It's pretty far from the kernel, right? With a few layers separating it. So rings 0 through 2 are mostly for drivers, stuff like kernel modules, and all of those things that you would kind of need more access to the hardware for. Yeah, and then the kernel itself is pretty much the code for the operating system that Linux uses to, yeah, what's up? Yeah, this application is at the bottom there. Yeah, sorry about that. Yeah. So, yeah, right. So kernel modules, I think I'll cover them later, but they're kind of ways that from user space you can have some input into the kernel and get it to do things that it wouldn't normally do. Which is very useful for all kinds of malicious purposes and legitimate ones too, I'm sure. Yeah, okay. So system calls, right? So in kernel space, the kernel makes system calls, okay, at ring 0. So system calls are these functions, methods, functions, whatever you want to call them, they're defined in the kernel, and it's pretty much how the kernel gets things done. So whenever you're running any kind of script or program or executable file on a Linux machine, what the kernel is doing is basically taking all of that high-level programming language and whatnot, and through glibc or libc.so.6, that file on a Linux machine, what it's doing is it acts as a wrapper for that executable file or script or whatever you're running, and it pretty much translates that into system calls that the kernel is going to use to actually execute what actually happens. And you can see all of that if you use the strace command. You like strace ls, and you can see all the system calls that ls uses. So it's pretty cool. And you can find all of the system calls on man pages. There's some great websites for kind of going through and finding all of them and seeing what they require in order to run, what the arguments are, that kind of thing. And you can also call them syscall directly if you're running C for Linux sometimes. Depends on your permissions. We have like user mode syscall type things. It's weird, but yeah, anyway. So kernel modules, I mentioned earlier, kind of like custom additions to the kernel. So like for example, you can write a rootkit that just sits in the kernel and does everything you want it to do, and it runs at the highest permission level, which is like above root, essentially, because it exists outside of the concept of users. It's just like all powerful. So a common way to think so if you're writing like a net filter type thing or a firewall type application, you can make it run as a kernel module that sits at the highest privileges and kind of oversees everything and sees all the packages that come in, that kind of idea, that concept. If you want to write like antivirus or endpoint detection response systems, EDR, which is a pretty big thing right now in the industry. The way you would do that on Linux is you would write a kernel module, you would load it in, and it would pretty much, if it's an antivirus thing, what it's going to do is check all the system calls that get called and make sure nothing fishy is going on. So it's basically a rootkit, but it doesn't do anything malicious. And so you can load kernel modules during runtime with insert mod, which is helpful. We don't have to insert it and reboot the machine to get it up and running. This kind of goes, it just kind of works. Unless you wrote it incorrectly and then you get seg faults and bad things happen. But assuming that you know what you're doing and you've tested it and things are going good, then yeah, you just load it and everything's great. Yeah, so it's out EDR, rootkits, and it's software. Cool stuff. All right. So yeah, net filter. I mentioned this. It's the kernel's way of intercepting packets. It's kind of this big library system thing that it's like it's what IP tables uses and other firewall applications. They pretty much just take from net filter. It's basically a front end for this net filter thing in Linux, and you can insert all the packets. You can control where they go, what permissions, those kind of things. So from a routine perspective, you can like write your own firewall if you choose to do that. From a routine perspective, you can write your own like anti-firewall and say, hey, the moment you get a packet that looks like this, just let it through. Don't worry about it. Yeah, so it's pretty cool, that filter type stuff. And you can do that with kernel modules. So if you wanted to make your own like filter special rules and let my special packets through, you would load that through a kernel module, typically. All right, so eBPF, this is the extended Berkeley packet filter thing. It's built on BPF, which was this old packet filter for packet analysis. So things like Wireshark, whatever you can think, kind of along those lines. BPF is kind of an older library used for Linux to get that data from the hardware. And eBPF just takes that like basic foundation concept of tying the space between hardware and user space to run kernel space code from user space without like necessarily having to use the kernel module. Yeah, so eBPF is just this big library where you can do that kind of stuff from. And actually, a lot of like modern EDR will use eBPF instead of kernel modules, just because it's easier to work with and better at not seg forcing. And yeah, it's usually written in C with eBPF libraries. Yeah, an API is the way to think about it. An API is communicating between user space and kernel space, really. So you can do some really cool, powerful stuff like this. You know, you can run things from kernel space, and that always means basically you can do whatever you want on the machine if you're able to get your eBPF to run, which would be root privileges for. All right, so PAM. You might have heard of PAM before, but not really known exactly what it is. It's a pluggable authentication module. So once like you learn about PAM, you start to feel really insecure about how authentication works on your device because you realize that there's like extra authentication rules for everything that pretty much uses authentication on your machine, typically. Yeah, so it's a very modular way of controlling authentication to like specific services and things like that. You can see all of your PAM configuration stuff in SCPAM.d directory. And the general syntax for this is your module interface, so auth account session in that example down there, which basically says this is what it's for, so auth pertains to all things authentication accounts, user accounts, session, active sessions. There's also password for changing passwords, stuff like that. Control flag would this picture just include, which isn't a great example, but you'll see that one. This just means, or include would just say like, include the next thing. So include the next module, which is system auth, which is some other module that we're actually going to take a look at. And then we can arguments and we can put them in there too. But yeah, so looking at this, right, you see that some important ones to know are, splendid. So this pam unix.so, that's just like the default way of typing in your password into Unix, right? So when like you do sudo whatever, just enter in your password. Pam unix.so. So you can see here that it's usually going to be required, as in like you have to pass it, and then they define the success and failures up here for that kind of stuff. And yeah, I mean there's a ton of things with PAM. Most of these are just kind of like, okay, if the first time you type it in doesn't go great, then fail safe type thing wants to run, or yeah, so you can look at what all these things do. But pretty much a good way to mess with PAM, like we're going to do something malicious. You just go through, find all the Unix.sos and just make them optional. And then it's like, it's whatever. You don't need actually authenticate. So yeah, something to keep in mind. PAM is pretty scary. because of how easy it is for someone to just go in there. So like if someone has root access, you just kind of go in there and mess with things kind of discreetly. It can be hard to catch. Yeah. So last topic for today, I think, is SE Linux, which is Security Enhanced Linux. It's originally developed by the NSA. I think it started out as a, I think they made it as like a kernel module, pretty much like a big fancy glorified kernel module that they could load in to make, Linux more secure. Yeah, so it's a kernel level application of Linux security module, which pretty much just a kernel module. And yeah, so it uses this concept of mandatory access control, where the rules are set by system, not the user. So it exists above the concept of users. Like there's no root user in the kernel space. It's just system, and that's where everything is set. So no user, even if you're root, has the power to go in there and mess with anything and change what SELinux says. So it's like someone just active got in there, even if they have root access, even if they're the root user, they can't do anything because the rules are set by SELinux, right? So that's the motivation there. And then yeah, then discretionary access control is like the opposite idea of mandatory access control. So as opposed to mandatory access control, is discretionary access control, which has permissions controlled at the user level, right? The accounts and groups and that kind of thing. Yeah, and then you can configure SELinux stuff and sysconfig SELinux directory. Yeah, SELinux is commonly thought to be like a huge pain in the neck because it is, but yeah, it could be annoying. But supposedly it's good for your security. All right, that is all of my slides. Are there any questions? Yeah, what's up, Chase?
What's the general idea around doing a pan backdoor?
Doing a pan backdoor?
Yeah. How would anybody?
So common one you see is like SSH, right? Where to SSH onto this box, you have to type in your password. You can like edit the config file. So the way PAM works is that every single service like SSH, sudo, like here I'm looking at the permissions for sudo, right? All of these services have their own PAM configuration file. That gets written by whoever made that service because it's just good practice to include a PAM thing with it. So for SSH, for example, you would go into that service file and then you could change like the requirements for passwords and for accounts and things like that to create your own backdoor, so to speak. You can say that this user always has permission regardless of password, stuff like that. It's pretty, like you're pretty free in there to do whatever. So. All right. Any other questions? Cool. All right, thank you.